NASA's Langley Research Center, Evan Dill and Maria Consiglio. And finally, Annie Bullock from the Navy's Crane Laboratory from the Naval Surface Warfare Center. So what we're going to do is just take a few minutes for each of them to talk about their individual technologies, and then hold questions to the end. We'll probably do 7-8 minutes for each for the 45. And again, when we're done, we have a bunch of documents online that you can get from the site. And the Excel spreadsheet, as I mentioned, and any things you want to follow up on, you can contact me. My contact information is in that spreadsheet. So with that, with no further ado, we're going to start with Jeff Walenta from the Agricultural Research Service. Jeff?
Thanks, Kevin. Appreciate your time in inviting USDAARS to this event. USDAARS has had a fairly long, extensive work in this particular area, developing UAS applications and development and research over the past decade. Primarily, a lot of our particular research has been the use of small or smaller UAS to basically, do imaging of various geographic areas, particularly with the need of looking at or maximizing irrigation systems and actually determining where pests may or may not be located on a crop, and where to, particularly target some sort of response to that. In addition, we've also, had applications in weed management as well. A lot of the technologies we would use in this particular instances are fixed wing craft, multi-rotor hybrid systems, in addition to using a lot of different sensor technologies, of which we have incorporated ourselves or developed ourselves, in addition to technologies that may be incorporated from outside of the government, specifically, multispectral sensors, near-infrared, thermal, various camera technologies, and ability to sort of to analyze those particular images in a high throughput, maybe quick imaging system. A lot of that collaboration has been done with universities around the area in the West and all over the country, in addition to various companies that we will work with. In addition to the smaller, the UAS technology, we also have work in much larger aircraft or UAS aircraft. That work is limited to perhaps a fairly, one or two spots. One in particular is in my particular area, which is College Station, Texas. It's the Southern Plains Agricultural Research Service Aerial Applications Unit. They are probably more focused on maybe delivery systems, which would involve the need for larger aircraft and larger mechanisms, which brings about different challenges and needs. In addition to that, basically, I just sort of give our innovation needs that we're looking for with a partner. That would be ease of use, sort of a one-button push to do that. Better, smaller sensors that we can customize and work with our collaborators to do that. Fuel systems, smaller, longer life, and basically real-time imaging processing, which some of these images in some of the land area could get rather extensive. So having the capability to do that quickly and on site. And I'm sure, as I've seen in this conference, a lot of the issues with regulatory compliance and beyond the line of sight issues. So working on areas like that. We have a number of technologies on the shelf, but we're always willing and able to collaborate with our partners, and we can do so, and basically this is an opportunity to reach out and find those opportunities as well. I think that's a very good summary. Also, I want to mention that we've put on the website, the conference website, a very good article about a decade of unmanned aerial systems in irrigated agriculture in the West. That's a great sort of deep dive into some of the things we've done and some of the people you can perhaps collaborate with as well. Thank you, Kevin.
Thank you, Jeff. Now to Evan Dill, who's at Langley Research Center, a NASA laboratory in Virginia.
Hi there. Thank you guys for the opportunity to speak today. So I'm actually going to talk about two different technologies. The first one is something that we call Safeguard, and this was developed under NASA's UAS traffic management project. And what this is it was designed as a means of assuring compliance with certain conformance criteria. So I know that's a mouthful, but what it really means is we can take small UAS and ensure that you don't break certain rules that are limited by states that we define in advance. So this could be geospatial limitations, altitude limitations, attitudes, speed limits, anything like that. And we're going to assure that up to a very high certifiable level. So why do we need this? So the idea is for commercial aircraft, we have a whole lot of very good processes to make sure that they are very, very safe. But if you try to apply what we do for manned aviation onto the UAS world, you would cripple the industry. So you can't ask, especially the small UAS, you can't ask them to have very high size, weight, power of the equipment that you're putting on. You can't go through full certification procedures for everything on board the aircraft. So the idea that we came up with is instead of trying to certify every aspect of this vehicle up to a high level of assurance for safety reasons, what if we could pick out the very specific things that will keep it safe and just assure those things? So that's what Safeguard was designed to do. And the main one that you get the most bang for your buck with is certifiable geospatial constraints. And what I mean by that is a means of making sure that a vehicle can't go into areas that it shouldn't, and it can't leave areas that it shouldn't. So if you define, I want to perform an operation of a UAS in this area, and I don't want to go into those areas, you can put that into Safeguard, and Safeguard, through an independent means, independent of every other thing on the vehicle, can ensure no matter what the failure is on board the vehicle, we can guarantee that you will stay within those boundaries. So we started off with some analysis of concept of operations of some various UAS applications, from precision agriculture to cargo delivery over a long distance. And we essentially proved out the utility of something like Safeguard, where you can ensure that you don't go into areas that you shouldn't. And what you do is you end up reducing the amount of hazards that you have to worry about by an absolutely huge margin. So a couple of little notes about Safeguard really quickly. So it's independent of everything on board. It can actually be configured so it's not completely reliant on GPS in and of itself. So if you look at the navigation suite of sensors on most small UAS, you're usually limited to a fairly cheap GPS receiver and a low-grade inertial. And GPS is a single point of failure there. So we actually have a means of making it such that our system can still enforce geospatial constraints even in the situation where you lose GPS. We have all of our base algorithms going through formal verification to make sure that all of the underlying math that we're using is correct. And we've actually taken this system through an internal NASA certification process. So with respect to having credence to actually fly in the national airspace, we have a very high bar that we've hit on the certification of this system. So NASA has put a Class B certification stamp on it, which essentially means that's the second highest certification that NASA can achieve. And what that means is that we would stake the success of a space mission, a non-human space mission, on this succeeding. So when we say that it will, in fact, enforce the things that we say it will, we actually have the proof and documentation to say that it, in fact, will absolutely enforce those things. We can do any sort of polygon that you can imagine, any number of polygons with respect to defining stay in and stay out regions. And I believe Kevin has put a slide up on the site that kind of lays out the difference between what you see in the Safeguard system versus standard embedded geofences. So why this is different than what's currently on the market. So the second thing that I'm going to talk about is something that we've called locked in. And what this is the location corrections through differential network systems. And the entire premise here is you have a whole lot of very cheap devices out on the market right now that use GPS for all kinds of different applications. And the chipsets to receive GPS in, say, a cell phone are incredibly cheap. We're talking 10 cents-ish. And the accuracy that you see with things like a cell phone, a smartwatch, a tablet, anything on those lines is usually about 5 to 20 meters of accuracy based on GPS. So that's great for some applications, right? You can use your phone to navigate in your car from one location to the next. But for other applications, that type of accuracy of 5 to 10 or 5 to 20 meters just isn't good enough. So what if you're in a large crowd and you want to use E911 as a rescue? What if you want to go out onto your driveway and define where a UAS is going to drop a package? Or if you're going to say, I want to be picked up by a future urban air mobility vehicle and I'm here. If you want to use a cell phone, a networked smart device for an application like that, you need much higher accuracies. So what we did was we leveraged a bunch of different techniques that are out there now, combined with the fact that most smart devices are starting to receive what's called carrier phase information. We're able to get usually on the order of somewhere between factors of 5 to 10 times improvement on reliability and accuracy of a cell phone. And this requires no change at all to the device itself. So you can go, we have multiple examples in published papers in which you can go from, say, 10 meters of error on a cell phone all the way down to 1.5 meters with a very low standard deviation. So we can increase the accuracy of a cell phone, a tablet, a smartwatch by almost a factor of 10 in many cases without having to change a thing on the device itself. So it's just processing and infrastructure around it that's already in place. So that's all I have on both of those things.
Thank you very much, Evan. And sticking with Langley, I'd like to introduce Marie Consiglio, talking about related technologies also going on at Langley. Maria. Maria, are you on mute by chance? I see you. Uh-oh. Okay, we're having a problem with Maria. So Annie, you're up. Annie Bullock from the Crane Laboratory of the Naval Surface Warfare Center.
Hi, thank you, Kevin. I appreciate you introducing me and for inviting me to talk today. As Kevin mentioned, my name is Annie Bullock, and I'm a member of the Technology Transfer Office at Naval Surface Warfare Center Crane Division. I'm going to take a little bit of a different tack today from my colleagues in that most people have never heard of NSWC Crane. Generally, if I'm speaking to a room of people, one of the first questions I would ask is, has anybody here ever heard of Crane? Did you know that there's a Navy base in the middle of southern Indiana? And I can honestly tell you most people, unless you're in the federal government, have no idea that Crane exists, where we're located, or anything about the lab and the facilities that we have there. So I'm going to give you a brief overview of our lab today, talk a little bit about the technology transfer program and some of the assets that we have that you may want to get access to, which does include our intellectual property, but there's a few other things I wanted to touch on as well. And then lastly, I'm going to talk about areas of current research and development that we're working in and that we're currently looking for partners in industry and academia to work with us on. So that's what I'm going to touch on today. So a little bit about Crane. Crane is located in southern Indiana. It's the third largest Navy installation in the world, so it's very large. It's about 100 square miles, and it's in the middle of rural southern Indiana, but that gives us the opportunity to have some really unique facilities and capabilities that a lot of other places can't have because they're constrained by space or urban areas. We have over 2,000 scientists and engineers that work at the lab, and we serve all the different DoD and military branches, including not just the Navy, but the Marine Corps, the Army, the Air Force, the Coast Guard, U.S. Special Operations Command, as well as other military organizations, civilians, and also foreign military organizations. So we have a very large customer base, and we work for everybody there at NSWC Crane. Like I said, we are a very large and unique facility, but we do have 3 focus areas that we specialize in. One of them is expeditionary warfare, and this is the tagline for this focus area is that we're equipping the world's most elite warfighters to be ready for combat environments. So what does that mean in terms of what technologies that we're developing? We're working with sensors, we're working with communications, maneuverability, munitions, small arms, all of those different areas Crane is an expert in. Strategic missions, and these are technology solutions to detect threats and high reliability hardware. So what that means in terms of the technology that we're developing is that we are focused on trusted electronics. If you are concerned about your supply chain, we can guarantee you a trusted supply chain. We focus on microelectronics as well as anti-tamper of electronic devices. Security systems, logistics, acoustics, and underwater systems are all focuses of our strategic missions focus group. And our last focus group is electronic warfare. And this is solutions for controlling the electromagnetic spectrum and gathering data. So that includes batteries, high energy density storage devices, RF spectrum, electro-optics, anything that has to do with the electromagnetic warfare spectrum, we have it covered. So a little bit about technology transfer. Our focus at Crane is technology transfer is getting access to you, so people in industry and academia, access to the assets and facilities that we have at Crane. So like I mentioned, that does include the intellectual property, but it also includes our subject matter experts, those 2,000 scientists and engineers. Those are all available to you to get access in all those different specialized areas that I touched on. And it also includes some unique facilities that might be one of a kind in the world at Crane. The unique facilities that I was mentioning, we have 270 buildings on Crane, so that includes a lot of lab space, a lot of floor space. We also have Lake Glendora, which is just down the street from our base, but it has a hydroacoustics testing facility. It has a UAS range, so you can get access to those testing facilities if you need them. We have access to Zubowski Flats, which is an ordnance test range, Muscatatuck, which is an urban training facility. It's the largest DoD urban training facility. So if you have some kind of test that needs to be done in an urban environment with your UASs, we can get you access to a place to do that kind of testing. We have chemical, mechanical, and thermal analysis facilities. We can test materials. We can do radiation testing. We have tons of battery testing capabilities because we have a huge energy group. So if your UAS has a unique battery or energy requirement, you can come there and get some testing done in those unique facilities that we have. We have a lot of facilities, and I didn't really want to take the time to list all of them, so I just touched on a few. As Kevin mentioned, with FLC, it's a consortium of all the labs, and they have a website that's really great. It's called FLC Business. And if you're interested in some of the other facilities that Crane has, we have our profile filled out there that has a complete, pretty in-depth look at all the facilities that we have. So please take a look if any of those are interesting to you. And if you don't find something that fits your need exactly, but you think we might have the specialty and the expertise for it, please just reach out to us because we have a lot of facilities at Crane, and if we have the right things, we can get you access to them. And then lastly, I did want to talk about our intellectual property because I know that's what we're here for today. Crane has over 300 patents, and our patent portfolio is fairly young. About 15 years ago, they started ramping up our patent portfolio at Crane, so most of our patents are younger than 10 years. So that's a really great thing about our portfolio and the intellectual property that we have. We have a huge range of intellectual property that might be something that you're interested in especially in the UAS industry. industry. We have a ton of sensor technologies, system of system technologies. We have some technologies that are related to controlling UAVs and taking control away from an operator. We have antenna technologies, materials and metamaterials. We have a few UAV designs that might be of interest, some lasers, electro-optics, communications, free space optical communications that are of interest sometimes to people who are working with UAVs, and charging and wireless charging of UAVs is also a special area that we're working in, as well as GPS and location determination as well. One specific technology that I was going to mention today, I wasn't going to go into a deep dive of any of our technologies, but one of my favorite UAS technologies from Crane right now that I'm interested in pushing out to industry is called DIAT. It's the Drone Integrated Acquisition Tracker, and it's actually a passive drone detector. So this would be something that's on the ground or on a vehicle or on a building, and it has the ability to lock onto and detect RF signals from a UAV, tell you where that UAV is located, and then it's able to stay locked on and track it. It can be a portable system. It has great battery life, and actually one of the cool things about Crane is that we're focused on getting technology into the hands of the warfighter directly. So that would include with this one, it has a very high TRL level. It's been prototyped, it's been built. They've taken it out to a range and tested it. They tested it to a range of 4 kilometers. It works great. They're only limited by 4 kilometers because that's how big the range was. So there's some potential there if anybody's looking for a drone detector technology that we can give you a tech data package if you're interested in licensing and running with that one. So that's just one specific technology in our portfolio that's related to UAS, but we do have a ton of other technologies as well. So lastly, I wanted to touch on our current work that we're doing. So I know that things that are issued patents, technologies that have patents on them, usually a few years old, and people in industry are always looking for the latest and the greatest, what's happening now. And so I did want to tell you that we're still working with UAVs. We're still working with UXSs, which is, sea, land, air, all the different unmanned systems. All of our focus areas at Crane are actively working on those, and we're also actively looking for industry and academic partners as well. So just a quick cap of a quick look of things that are happening in our technology areas with UAVs right now is that we are heavily engaged in utilizing machine learning and artificial intelligence with UAVs. So there's an extensive amount of work that's being done with deep neural networks, and especially towards counter UAS applications. And in fact, when I was talking to one of our subject matter experts, Dr. Arthur Lobo, he said, hey, if you're going to talk to this panel, I am looking for experts in neuromorphic chips, specifically True North and Intel chips. And he said, hey, put it out to your people. I'm interested in working with anybody who's working with neuromorphic chips. So please get in contact with me and I'll direct you to Dr. Lobo if that's something you're working in, you're looking for collaboration and cooperative development opportunities. And then augmented reality, we have a subject matter expert right now who's working very heavily with the ability to detect, track, and visually show somebody where a drone is, but they don't want to do it with heavy equipment. They want to be able to integrate it onto an Android device, a cell phone, and then have a pair of the alternate reality glasses and help operators be able to see and find drones at the time that they're looking for them. And then lastly, what I wanted to touch on was payload integration. We are always looking for different technologies that can go onto UAVs and be used by people that are out in the field, people who are trying to do security, anything like that. So we are looking for and are still working in the area of payload integration on UASs. So sensors, jammers, data collection devices, anything like that, we are working on it. And we're also looking for partners. I believe there is a broad area agency CRADA announcement out right now looking for partners. So if you're tied into that network, please go ahead and let us know that that's an area you're working in, and we'll connect you with the right people at Crane. So I think that was my overview that I wanted to do of Crane. Thank you guys for the opportunity to talk about my lab and the work that we're currently doing.
Thank you, Annie. And she mentioned what a CRADA is. And so a CRADA is a cooperative research and development agreement. It's one of the key tools that federal labs can use to enter into partnerships with industry. And it's a pretty open-ended agreement that you can negotiate. One of the key elements of a CRADA from industry's point of view is that if new intellectual property is created by that, the partner to the CRADA, the company, has first right of refusal for an exclusive license on that intellectual property. The other traditional, as I'm on the topic of agreements, the other traditional one is a patent license agreement, which is exactly what it says. And also there is, for some agencies, the DoD, NASA, and a couple others have something called an other transactions agreement, which is far more sophisticated, but it's another way where actually money can be exchanged to do work. But in all those cases, those follow when you talk to the researchers at a lab and you find an area where you both agree that common research should be done. But a CRADA is a cooperative research and development agreement. So thank you, Annie. Maria, can you hear me? We're going back and forth. Okay, well, I'm sorry, probably we have some technical difficulties with Maria. I see her face, but I'm unable to hear her, so. And I see her, she's in, so we're just having some technical difficulties. So with that, if she can, Maria, if you can get in, just chime in, interrupt me, please. We can go to some questions from everybody. I do have one for, back to Jeff. Could you restate the group at Texas A&M that you're working with and possibly type it into the chat box so people could see it?
Yeah, absolutely. The major center is the Southern Plains Agricultural Research Center. The specific group at the center is the Aerial Application Technology Research Unit, who is actually headed by Dr. Bradley Fritz. So I can type that in as well in the chat. So
that'd be great. While I have you, do you want to talk about how ARS, their participation with industry is in any particular way? Since a lot of people don't even know about ARS, and kind of when ARS with drones, people are a bit, I think, they don't naturally think of technology when they think about the Agriculture Research Service.
No, that's a great question. And coming from a drug industry before agriculture, I didn't realize how much automated systems were in agriculture, including in the field as far as tractors. So it's next iterative state for drones and aircraft to be going that route. As far as collaborating with ARS, as you mentioned, there's the CRADA, Collaborative Research and Development Agreement, which is great for, if you anticipate a commercial product or development at the end of the research program, because we do like to get into collaborative relationships with a focus for a product at the end point. There are other agreements that we can bring in, cooperative agreements. Also, there's a material transfer research agreement that we can bring technologies in where perhaps we're just looking it over, melding it with something that we have. So there's other aspects of that can get funds to ARS to help with you. In addition, I wanted to bring up a program that our Agriculture Research Partnerships Group tends to focus on, and it's a plug for them, as they're a great resource for the new technologies that might develop. But in addition to the CRADA, we do have a sister agency, NIFA, and I'm going to be at a loss to national. It basically is the SBIR granting. I'll type it in below once I figure out what NIFA stands for. But it is the SBIR granting agency. We have done CRADAs and collaborations to win SBIR awards, which actually brings fundings to the company and the government to move this particular research forward. So that's just sort of a general overview. Thanks, Kevin.
So since you mentioned SBIR, and some of you may not know what that is, that's the Small Business Innovative Research Program. It's been in place with the federal government. All the labs do it for decades now. It's for companies of 500 employees or less. Every laboratory, every agency will put out a solicitation twice a year usually about the areas that they want to work in. It's a couple of 3 phases long. Phase 1 is usually proof of concept. Phase 2 can get up to close to $1 million in funding. And then phase 3 is what we call commercialization. You're able to get a contract with the government, or you've pushed this along that you have a product. And the beauty of all of that is, again, you would control the intellectual property. You own the intellectual property that would fall out of an SBIR. The government retains some uses if they want to do it for mission, but from a commercial point of view, you totally control and own the intellectual property that comes from an SBIR. And if you're in partnership with industry, if you're small, they have an STTR, which is a similar concept, but you need to partner with the university, where the university is effectively the prime contractor. So those are the two related programs. Evan, I have a question for you regarding the difference in terms of geofencing between Safeguard and what exists already in the industry.
Sure. So most, especially when you're talking about the smalls, most drones have some sort of embedded geofence already on their autopilot. So typically what you see out of those is you see the capability of defining a singular stay-in region. And a lot of the times this is a very simplistic thing, something like a box, something like a radius from a point, so a circle. But what we have the capability of doing is any number of different stay in or stay out regions. And you can make them as complicated or as many as you want, right? So you can draw very, very complex convex or concave polygons, and you can make them stay in, stay out. So you can make regions that, for example, at Langley, we fly UAS on center. And with that, what we've done is we have a stay-in region of the flight area that we're authorized to fly in. And we have stay-in regions around all of the buildings, defined with vertices at the sides of all of the buildings, as well as some other areas that are very complicated. So we can adapt to incredibly complex environments, whereas a conventional autopilot geofence can't. We also have the capability of operating independent of GPS. We're not dependent on anything on board operating properly. So if you lose control of some sort of control surface, if your autopilot malfunctions, even if your battery dies in and of itself, we can still ensure containment up to a high degree of reliability. And of course, the other thing is most conventional autopilots, their code that their geofence is based off of is typically open source, and it's not necessarily vetted for reliability. And that's perfectly fine. It offers quite the capability at a low cost, but that's not something that you want to count on for safety critical type applications. So when you need high levels of reliability on not flying into certain areas for security or safety reasons, the onboard geofence is probably lacking for what you would want to do there, whereas Safeguard actually has the pedigree, testing, and documentation to prove that it's an assured function.
Thank you. Annie, two questions. One going back to, it has to do with the agreements. One is, can a company augment their own portfolio by doing a CRADA and working with you? And also just expand about examples how TechTreasure has worked successfully, just so the audience kind of has a better idea of working with Federal Labs.
Sure. So to address the question, can a company use a license agreement to augment their own internal R&D as well as a CRADA? Absolutely. That's not a problem at all. You can use a patent license agreement if you are interested in working with our intellectual property. That gives you the rights to make, sell, and use whatever we have patented. And a CRADA can be used both with and without a patent license agreement. So if there's an area that you're interested in working in and it intersects with those areas that we're already working in at Crane, we are happy to partner with you to work whether or not there's patented technology there. So absolutely, both license agreements and CRADAs can be used to augment your own internal R&D as well as your own internal patent portfolio. Kevin asked me to give an example of technology transfer and those agreements working well with industry, and I have a really great story about a technology and a company that we worked with and are still working with now. A few years ago, we had a startup company that came to us. They were interested in working with robotics and wearable technologies to monitor human performance. And we had a patent in our portfolio that was invented by Dr. Rob Walker. He was an avid runner, and he was interested in power output during running or other walking type motions as a way to track the work that you're doing instead of looking at number of steps or distance that you've gone. And so the company was interested in this technology. Rob was interested in working with the company to bring this technology further into a commercial market. And so we signed a patent license agreement with the company, giving them exclusive rights to that particular piece of patented technology. And then we also signed a cooperative research and development agreement with Dr. Rob Templeman as the primary on that, and the company. And so they were able to work together. They helped take the technology. Crane has one of the DoD's only printed circuit board labs, as well as some polymers groups that are very specialized at Crane, and both of those groups were willing to work through the CRADA to help them do some prototyping of their insoles for shoes. And we did some initial early prototyping. We did some beta prototyping after the first set was tested. Able to work with the company and help integrate what we had developed at Crane with their overarching human performance system. And so that company turned around and they were working with other DoD programs to help integrate their system with Human Integrated Performance Optimization was the name of the program. So they were working to bring their technology to the warfighters. So that was partly our technology and partly some of the other technologies that they'd licensed and partly some of their own in-house developed technologies. And they were helping create this system that was monitoring and improving the lives of our warfighter. So that was an absolute success from our viewpoint. And then on the other hand, in 2018, the summer of 2018, they released a commercial product on the market. So you can go on the web, you can go to the website, you can buy their system. It's being used in industrial applications such as warehouses to help optimize how people are lifting and moving in warehouse environments, and some other applications for their technologies. But this is a great win for both Crane, for the warfighter, and for the small business as well. So that's an example of how technology transfer agreements can be used to help move technologies and foster better products, both to benefit the warfighter and also the commercial industry.
Jeff, do you have similar stories with ARS in agriculture and related stuff?
Yeah, stumbling for the unmute button. Yeah, actually, we really had actually accolades that were received from the Federal Laboratory Consortium, which was your group, for an Excellence in Tech Transfer and Focus Award for a technology related to, I don't know if you're flying, you know, from coast to coast, you look down in the west and you see the circles on the ground where the crops are growing, where the irrigation systems are there. Well, we basically, worked with 3 different companies, established CRADAs with those companies, developed various inputs and systems related to those, that technology for managing those things autonomously, and basically had these systems, be able to operate on themselves and maximize water input or output, I should say, for saving water. So that was, and ended up with a exclusive license to a few of the companies, and that product is now being sold nationwide, actually worldwide, I should say. That it started in the US and now is in various countries. And sort of thinking about this particular forum, I know that the scientists are trying to take it to the next level with, using, not sensors on the ground, but sensors in the air to start managing systems like that as well. So yeah, it was a very good multi-year, multi-company, multi-party. I think even Canada was involved as well for some of the research and field trials as well.
Thank you, Jeff. So we have a few minutes left. Any other questions from our participants, or we'll start wrapping this up? I'm looking down at the chat right now. Well, again, I apologize that Maria Consiglio could not make it, but what we got here? Searching for creators and other projects. Anyone want to do detect and avoid? Evan, can you handle some of that? Just to talking up, there's a question there. Exists creators detect and avoid from Phil Hurd, from Frederick Renoco, for Annie. Evan,
yeah, sure. So it's highly unfortunate that Maria can't speak right now, because that is actually her area of expertise. So if you wanted some information on some of the detect and avoid work that NASA's been working on and the Icarus system that Maria was going to talk about today, I'd be happy to put you in contact with Maria. You would be very interested in the work that she's doing.
And Maria had sent me documents that are posted at the site for the Icarus program that is on Detect and Avoid. And there's a video we put up there and some other documentation to give you an idea of the work that she is doing. Annie, there's a question for you, I see.
Yeah, I tried to answer it in the chat, but if that did not come through, the name of the drone tracker is DIAT, Drone Integrated Acquisition Tracker. And if you'd like more information on that, please feel free to give me a shout out, send me an email or something, and I'll forward you our technology profile on that.
Is anyone interested in working with larger, Evan, again, you're the pure technologist of us here, the one from David Gonzalez, can you help me there? You're on mute, I think.
Thank you, caught me early. So the answer is, the question is anyone interested in working with large VTOL drones that can carry 200 pounds or more? So the answer is yes. There's different applications in which we're thinking about VTOL capabilities that are fairly large. We've worked with a company that will go unnamed, but they do precision agriculture and use for crop dusting purposes VTOL UAS that are fully autonomous and carry well more than 200 pounds. We also have, if you're looking at more of a blended type solution, so VTOL capabilities, but also cruising capabilities, that's a very hot topic right now with respect to the field of urban air mobility. So urban air mobility, think air taxis within a city. The idea of larger aircraft that can do vertical takeoffs and landings is something that NASA is definitely interested at the time.
Okay, well, with that, we have a minute to go, so thank you all. I'd like to remind the participants that, again, posted on the website is an Excel spreadsheet that lists all the federal government's owned patents in the area of autonomous systems. The first two columns is a taxonomy, so you can find what you're looking for. But we kind of view this more as a way to, as a proxy for the expertise. So if you like a technology, if it's close into the ballpark, you will see who the researchers are, you see who the lab is. That's where there's ongoing research today. So for instance, you got some stuff at Langley, there's probably a dozen labs in the country doing work in these areas. And the role of the FLC is to help get you to those labs. So you'll see my contact information. You can also go to federallabs.org, which is where you'll find, that's the website for the FLC. You'll find FLC Business, which is the website that Annie was talking about. It has a ton of information about also all the federal labs and the facilities and the intellectual property that they have. So with that, we're right on the button. I'd like to thank everybody. I got a note from Maria. She sends her regrets, and we understand this stuff happens. This is the new world. So again, you have Maria's information for areas that have to do with detect and avoid in the Icarus system. Please go to the website, see her documentation, and please contact her directly. I'm sure she would be very happy to speak with you. So with that, I think our time's up. I don't know how these are supposed to end. Amanda, can you type me something about how these are supposed to end?
Just like that. Thank you guys so much for being here today. We really appreciate you sharing all of this, just this fascinating stuff. I mean, you guys really just scratched the surface. I know how large the technology portfolios in the federal labs are. And this is just, you know, the things that you talked about today are some of the more immediate, market ready, super relevant kind of technologies, but there are so many technologies available. So I really can't encourage our audience enough to take the time to find out more, to contact you. I know in this day and age, there's all kinds of things that we can search, but that's what's so great about sessions like this is they can put faces to names, they can pick up the phone and they can talk to someone and say, this is really what I'm looking for. So thank you so much for bringing kind of a face and a human touch to technology transfer.
Well, thank you all. Goodbye.
All right, take care.